Now we're going to look at factoring quadratics, or just factoring polynomials in general. Okay, so factoring just means finding what you're going to multiply to get an expression. So you're kind of working backwards a little bit. It's the opposite of FOILing and our box method. So it's the opposite of multiplying. Now I'm going to figure out what I multiplied to get that expression. The three ways we're going to look at in this video is GCF factoring, grouping, and difference of squares. So, GCF, greatest common factor. Okay, a factor is something that multiplies to get an expression. Right? So, example, the factors of 6 are 1 and 6 and 2 and 3. Okay, so the greatest common factor is the biggest factor that goes into all of your terms. So I'm looking for the number and or variable that goes into all three of these terms. We've got 9y cubed minus 6y squared plus 3y. So if I'm thinking, lost my mouse, if I'm thinking GCF, all right, of 9, 6, and 3. Okay, try the smallest number first. See if it goes into everything. Sometimes you might have to go even smaller, but sometimes it'll be the GCF. So if I look at 3, 3 goes into itself, it goes into 6, and it goes into 9. So my GCF is going to have 3 in it. Then whenever you look at your variables, y cubed, y squared, and y, it's always going to be the smallest exponent. All right, so my smallest exponent here is y to the first, so that's part of my GCF. Once you find your GCF, you're going to pull it out. So I'm going to put my GCF on the outside, all right, and I'm going to divide. I'm going to take out that 3y from all of my terms. So if I have 9y cubed, and I divide by 3y, I take that 3y out. 9 divided by 3 is 3. Y cubed divided by y, had 3 y's, took one out, got y squared. Negative 6y squared divided by 3y is negative 2y. And then 3y divided by itself is just 1. Don't lose that term. All right? 3y divided by 3y isn't 0. It doesn't just go away. You still have to have something there. All right? This is factored form when you take out your GCF. You can always check in any type of factoring that we do by just multiplying it out. So if I want to multiply this, I have to distribute the 3y. So 3y times 3y squared is 9y cubed. 3y times negative 2y is negative 6y squared. And 3y times 1 is 3y. And that's where I started, so I know I did it right. Now for this one, if you want, go ahead and pause, see if you can work through it and get the answer. If you're not quite sure what we're doing, just keep following along. I want to work through it. All right, so I want to factor 24b cubed minus 18b squared plus 18b. Okay, so I'm going to start by looking at my numbers. I'm going to start with the smallest number just to see if it's going to be my GCF. So my smallest coefficient is 18. 18 goes into itself over here, but it does not go into 24. So that means I've got to start getting smaller. All right, so a smaller number that goes into 18 is 9. All right, 9 goes into these two, but not 24. So we got to get smaller. So another smaller factor of 18 is 6. 6 goes into 18 and 24. So my GCF is going to be 6. Okay, you could do that from the other end too. Start small. 2 goes into everything. So does 3. Right, 4 doesn't go into 18, but it goes into 24, and then 6 is the next one. That's the biggest one. All right, look at my variables. I've got a b cubed, a b squared, and a b. They all have the variable, and my smallest exponent is 1, so I'm going to pull out my b. So my GCF is 6b, so I can automatically cross out b and d. All right, once I take out my 6b, okay, 24b cubed divided by 6b is 4b squared, right, which alone tells me that a is out, so my answer must be C. But negative 18b squared divided by 6b is negative 3b, and 18b divided by 6b is just a positive 3. Right, again, you can always check your work by multiplying this back out, and we'll get right back to where we started. And there's C. Next, we're going to look at factor by grouping. The first thing you should always look for anytime you factor is a GCF. For no matter what type of polynomial or expression you have, GCF is number 1. All right? Then there's always going to be little patterns you look for. Anytime you have 4 terms, you look at grouping. All right? So that's what you're going to look for after a GCF is for 4 terms. And then you're going to do grouping. All right? So I'm going to look for a GCF. I've got 8, 10, 4, and 5. Okay? So my smallest number is 4, and it does not go into 5. Okay, so because 4 and 5 don't have a GCF, this whole thing, we can't pull out a GCF. All right, we're looking at the variables. I've got an A here, an A here, an A here, but no A here. So because they don't all have A's, I can't pull out a variable. And same thing with B's. This 8A squared is missing the B. Okay, so I do not have a GCF. I just have 4 terms. So 4 terms, I'm going to cut it right down the middle. Okay, I'm going to group the left side together and the right half together. All right, with each side, I'm going to find my GCF. So if I look just at 8 and 10, I have a GCF of 2. So if I pull out a 2, okay, the A's, I have A squared and A. So A to the first is my smallest one. And then 8A squared doesn't have a B, so I can't pull out a B. Okay, so 8A squared divided by 2A is 4A. 10AB squared divided by 2A is a positive 5B squared. All right, same thing on this side. Okay, I got 4 and 5, so I don't really have a GCF with the numbers, but they both have B's. So my GCF over here is just going to be a B to the first power because that's the smallest exponent. Always keep the sign of what's in front. So it's going to be a positive B. 4AB divided by B is just 4A. 5B cubed divided by B is 5B squared. If you notice, my parentheses are the same. Every time you do grouping, if you're doing it right, you're going to have matching parentheses. That parentheses becomes your first parentheses in factored form. So I'm just going to bring it down here. Right, and then my second parentheses is going to be whatever's left. So I've got this 2A and a positive B. So I'm going to put 2A plus B. This is my factored form. All right. Technically, from this second step to the third step, I pulled out another GCF. Both of them had 4A plus 5B squared, so I pulled that out and then put what was left once I divided. Okay, but all you do is you split it in half. You take the GCF of both halves. All right, whenever you're done, your parentheses should match up. If they don't match up, you got to double check your work. Okay, once they match up, that parentheses becomes your first one. Whatever's on the outside becomes your second, and this is factored form. Right, just like before, I can multiply this back out to check my work. And when I multiply it, I should combine all my like terms and then end up with the same polynomial that I started with. Just like last time, go ahead and pause, give it a shot. Try to do this one on your own, and then come back and check your work with mine. All right, so I see that I've got 4 terms. In my head, that means I'm going to have to do some grouping. Okay, first I look for a GCF. All right, so I've got 6, 3, 8, and 4. So 3 is my smallest one, but it does not go into 4 and 8. All right, so that means that because I can't go any smaller than 3, it does not have a GCF. All right, so I'm going to cut it right down the middle. On the left-hand side, right, my GCF is going to be a 3 because 3 goes into 6, and my smallest p is just p to the first power. 6p squared does not have an r, so I can't pull out an r. So my GCF is just 3p. Right, 6p squared divided by 3p is 2p. And negative 3p r squared divided by 3p is just negative r squared. All right, same thing on the right side. My GCF with 8pr and negative 4r cubed is going to be 4r. So I'm going to have a positive 4r because I keep the sign of whatever's in front. So I got positive 4r, 8pr divided by 4r is 2p. 4r cubed divided by 4r is just negative r squared. All right, my parentheses are the same, which means I'm on the right route. So I'm going to pull those down. and whatever's on the outside. 3p plus 4r. All right, the only difference with my answers is that the 2p minus r squared is second. All right, so I can cross out C because all of these have 2p minus r squared, and the 3p plus 4r is down here at D. Okay, it really doesn't matter what order you write your parentheses, but it's just, if you're going to try and set yourself doing a habit every time, just pull out the parentheses and write what's left. And the last way we're going to look at is difference of squares. All right, so first you always look for a GCF. Okay, even with difference of squares, first thing you always do, no matter what you're looking at, is do GCF. Okay, if you've got one. After GCF, you look for the patterns. If it's 4 terms, you're thinking grouping. If it's 2 terms, you're thinking difference of squares. Okay, now it's not always going to be difference of squares, but you got to be thinking, okay, I see 2 terms, might be difference of squares. All right, and it's what it sounds like. Difference is subtraction, so it's got to have subtraction, so 2 terms is subtraction. And squares, that's talking about a perfect square. A perfect square is when I can take the square root and get an integer. So, for example, 25 is a perfect square because I can take the square root and get 5. All right, 15 is not a perfect square because the square root is going to be a decimal. Okay, so I've got difference is subtraction. X squared is a perfect square, and 25 is a perfect square, so I can do difference of squares. The square root of x squared is x. The square root of 25 is 5. And now we just have a pattern. You take your first term, add the second. You take your first term and subtract the second every single time. So we have x plus, oh my, I don't know what that is. So we got x plus 5 and x minus 5. Okay. All right, got rid of that weird streak. This pattern every single time. Okay, it doesn't ever change. You take your first one plus the second, first one minus the second. All right, and just a little note, your variables are perfect squares if you have an even exponent. Okay, so for example, x to the 8th is a perfect square. Okay, the square root of x to the 8th, you just cut it in half. It's x to the 4th. All right, x to the 20th, perfect square. The square root, x to the 10th. Okay, every single time. If it's an even exponent, it works for difference of squares. All right, I want to factor 12b to the 8 minus 27c squared. Okay, first thing, always look for a GCF. So I've got 12 and 27. Okay, I know 3 goes into 12 and 3 goes into 27, and nothing else goes into both. 27 is just 9 and 3. So I can pull out a 3. Okay. This one's got a B, this one's got a C, so I can't take those out. So I'm left with 4b to the 8th minus 9c squared. Okay, I've got difference. 4 is a perfect square, the square root's 2. 9 is a perfect square, the square root's 3. B to the 8th and c squared are both even exponents. So that means I can take the square root. So the square root of 4b to the 8th, 2b to the 4th. Square root of 9c squared, 3c. So my pattern, I've got 2b to the 4th plus 3c, 2b to the 4th minus 3c. All right, but I'm not done yet. If I multiply this out, I'm not going to get back where I started. You can't forget your GCF. That comes down with it too. Now if I multiply all this out, I'd get back to where I started. All right, try this one on your own, and I'm going to work through it. First thing you do is look for a GCF. My GCF, 18 and 50, I know they're both even, so a 2 goes into them. Let's see, we got 2, 3, and 6, and 9. So I think my GCF is just going to be 2. They got 2 different variables, so I can't take out a variable. So that leaves me with 9d to the 6 minus 25f squared. My exponents are even. 9 and 25 are perfect squares, and I've got subtraction. Square root of 9d to the 6, 3d cubed, 25f squared, 5f. So then I just write my pattern. Don't forget your GCF comes down with it. And that one is B.